All right, welcome to another episode. Today we're going to be tackling something that is pretty near and dear to my heart, and that is observables. And so in this particular video, we're going to be writing observables from scratch. That's right. We're going to be writing a very minimal and sort of basic version of like a reactive X library, something like RxJS, or maybe from Java, RxJava, etc. There are many ways to implement observables, but sort of the interface and the method names and stuff I'm going to use, some of the design decisions I'm going to be using in this video are in line with, programming languages like JavaScript, Java, etc., and ReactiveX. If you come from the functional programming world or somewhere else, this may be different than how things operate for you, but nonetheless, we're going to be writing in TypeScript, and I figured that TypeScript is pretty easy to read by most people, and it also gives us a way to sort of document behavior with types, and hopefully improve the learnability of this. And so this video is probably good if you have like written a little bit of code using observables in the past, or maybe you've seen some online examples or something, but you don't quite understand it or whatever. This is a good video for you if you're sort of a beginner to intermediate, right? Or maybe you're even in a little bit more than intermediate and you want to delve a little deeper into how these things actually work under the sheets. And what we're going to be kind of focusing on in this video is actually how simple these things are. You can sort of, with only we'll see, really only maybe 100 lines or something, implement an observable library. And it won't have all the bells and whistles and safety and performance of some of the more tried and true implementations like RxJS, for instance, but it'll just show you how simple these abstractions under the sheets really can be. So anyway, I have this repo available on GitHub. This has already been written and is available publicly, and I will of course link it in the video description when I'm done. But we're going to be sort of live coding it as we go, and the idea is that we have some desired requirements and properties of observables that we want, and sort of an example code that we, our implementation should be able to do. You should be able to write something like this with our implementation. And, we're going to kind of go through this first and then do some actual coding. If you don't quite understand everything that is said here, I won't elaborate on these too deeply at the beginning. That's okay. I think the code will speak for itself a little bit better. And you can see how some of these properties are actually maintained when we write the code, because the code will actually be very short. Just some ideas about observables. In general, observables are just a way to link between a subscriber and a producer, right? So really, this is just like kind of pub sub, right? In a very general sense. Some people say that observables are like streams, et cetera, et cetera. That's kind of true. So there are, in observable lands, there are three kinds of signals. You can say next, and this is kind of, you can call it 0 through n times. This is just kind of like an emission, right? You can call error, or you can call complete. And both of these last two here are what we call terminal, which means that once they are called, the observable is sort of signaling that it's done, right? And so, as you can probably imagine, errors are for like some kind of exceptional case, or something broke, right? The stream is broken for some reason. And complete is sort of a way for the observable to signal to a subscriber that, hey, nothing exceptional happened, but I'm done, right? And there will be no more emissions for you from this point forward. Observables are also lazy, which means that nothing happens until subscription occurs. And they're also reusable, so we can take the same observable and subscribe to it many times, and each time we freshly subscribe, we will get the same behavior sort of fresh once more. And this is a bit of a confusing thing, since observables are often named in sort of async contexts, and I do think that they are very good for async work, but they're actually synchronous by default. What I mean by that is they are as sync as they can be, and this is actually a very useful property, especially for testing. But there's nothing about them that actually requires these signals to be async. And this is actually a sticking point for a lot of beginners because they come from, like, for instance, promises, which are always async. There is no option for a promise to be synchronous. Since observables are cancelable, this is another property of observables, they have some option to register a teardown or a destroy that occurs either when they are canceled due to, like, a subscriber saying unsubscribe, or because of one of these, like, terminal signals are emitted. They are also immutable and pipeable. So these are just more like, once you create an observable, it should be, like, unmodifiable. And the way in which we produce new observables is we actually take a previous observable and call a function on it and modify that behavior. And we actually return a brand new observable which has a modified behavior. We don't change the original one. And we'll think about, you know, all of these as we write code, but this one in particular is a little bit abstract, and hopefully it'll become more obvious later. So in our implementation, right, we're just going to have observables be functions. And that's the most simple thing. We don't need classes. We don't need, really objects or any of that stuff. We're just going to have functions. And so in our implementation, our API is going to allow these functions to describe the relationship between a consumer, an observer in observable lingo, and a producer, right? And so inside this function, we are going to be producing values using next, error, and complete to tell a subscriber signals, essentially, right? And most importantly, in our implementation, we will get to this as we start to write some more code. When you subscribe, subscribers can pass as few of these callbacks as they like. So, for example, in this example down here, I'm saying subscribe, but I'm only passing a next callback. I notice I don't have an error or a complete listener here, but that doesn't mean that the observable, for instance, can safely call error and complete. So despite us not passing these callbacks, observables themselves will be able to safely call all of the signals, and we'll explain what this means as we go. Subscribers can also choose to unsubscribe at any time. So here you can see that the result of calling subscribe is a subscription object that has a unsubscribe. And also, moreover, observables also have to be able to optionally return a destructor function. So in this example here, I'm creating an observable. So create is going to be our main API. Here is that function I was just describing, where this is literally defining a relationship between a consumer and a producer. So here we are calling set interval. So every second we are going to produce a new number. We're starting at 0, and then every second we're going to increment and pass that value via the next signal. And then, of course, we optionally have the opportunity to clean up after ourselves. So in this example, I don't want this set interval to keep firing after someone has unsubscribed, so I'm going to clean up that interval. And of course, this will be optional in our implementation. So with that, let's see if we can hop into some code and see where to go from here. So I have already written some code, some initial code here, but most of this is just some type definitions and things to kind of get us started. This file is currently only 40 lines of code long, about half of which is just type definitions. So the main API to our observable library here is going to be this create function. And so the result of create function is an observable. And of course, observables are some generic, right? The type of the emission, what someone calls next with, is generic. It could be numbers, it could be, strings, whatever, it doesn't actually matter. And so the main API, as we saw in this example, is create, where we pass to create a function which, given a consumer, does some production work, registers a production, right? And then also optionally returns a destructor. And so we will write the implementation here. This is our kind of our main goal of today, is to write the body of this function. But let's just take a look at these type definitions real quick, just to make sure we're all on the same page. So again, the argument to create is this kind of registration function. That's the type that I've chosen to name here. And again, it is generic over T. We don't know what the kinds of things that each observable produce, but essentially it is just a function that, given an observer, either returns nothing or it returns one of these deregistration functions. An observable, which is the result of create, is pretty obvious. It's just a thing that has a subscribe callback. And so to that subscribe callback, we can pass as many of these observer signals as we want. That's what this partial means in TypeScript. So we can pass next, error, complete, or any combination of those. And what we get back when we call subscribe is a subscription, which is nothing more than a thing with a .unsubscribe. And this event emitter, this is due to another kind of creator I will want to write down here, but for now we'll just skip it. But really, this right here, this is the entire API of our library, and it's actually not that much, right? So, we have observables, which have a .subscribe. We have subscriptions, which have a .unsubscribe. We have observers, which are these three callbacks. And we have a registration function, which draws the relationship between these like three objects or so. So I have also written down here, this is where I was going to go next, I have also written down here some additional kinds of creators, right? And so the results of all of these functions, as you notice, are observables, but and I've taken these names right from RxJS, of, from event, and from promise. The idea is that these are convenience methods. So we can always use the low-level create API to create any kind of observable with any kind of behavior we choose, but sometimes we just want convenience things. So for instance, of is given any number of values, I will just create an observable of those values. From event is extremely useful if you are in a browser context or some other kind of maybe UI context where you have events that you were listening to. You have some kind of event source, and then that emits an event like by name, right? So there's some kind of identifier for that event. So for instance, an event source might be a DOM element, and an event name might be the string click. And so the idea is that I can get quickly and easily I can get an observable of all of the click events on a particular DOM element. And from promise, this is also another convenience method, and again, we will write this during the implementation of this library, but the idea is that if you have a source that is a promise of type T, I can convert that into an observable of type T. So with that, let's get started. I mean, I think we have quite a bit on our plate already. And so we know right away to make an observable, we must return something that has a .subscribe. So let's go ahead and do that. So we can get rid of this to do subscribe. Okay, and we know that a subscribe returns a subscription, so we're going to get in here and we're going to return subscription. Okay, and so, wow, look out. So already we have gotten pretty far into this implementation, right? We've already kind of handled the observable interface. We have a thing that gets returned, which has a .subscribe. Okay, so the question is, what do we do from here, right? So we know we have a registration function, and so we know at the moment that somebody subscribes, we want to call this registration function, because to call this registration function is to start this process of producing values. And so we also know that when someone calls subscribe, they pass us some number of callbacks. So let's go ahead and utilize this registration function. So I'm going to call registration function equals, and I'll just make it a const now for now. So let's actually skip that for a second. Let's just call the registration function. And we want to do something a little weird here. So I could, for instance, just pass callbacks here. And that would kind of satisfy the thing. You notice that TypeScript is complaining. And so the reason it's complaining is we said that when someone subscribes, they may not pass us all of the properties of Observer. They may only pass us a few of these. But in our implementation, we have made a promise, and this is coming back to this issue of safety. We've made a promise that this registration function can always safely call any of these callbacks. And so you can see that, oh, maybe some of these might be undefined. That's really what this type error is about. So what I'm going to do is I'm going to actually create an observer, maybe something more like a safe observer might be a good word, or a safe subscriber or something like this. And so again, it has to have a next. And so I can either say callbacks.next or no op. And we need an error or no op, and we need a complete, which is callbacks.complete or no op. And so I need to, of course, define a no op. All right. So here, now we know that the type error has gone away, and that's because our registration function, for every one of these callbacks, there is guaranteed to at least be a function there. Even if the subscriber, the original subscriber, doesn't give this to these, we will just use no ops, and so that the person who receives this, the user of this observer here, can always safely call all of these functions. Wow, so already we've done a bunch of work, and we already have started, by virtue of calling this registration function, this register function, we have already started producing values. And so we know that these callbacks are going to start receiving values if the subscriber passed them. We're already getting there. And so I have some tests here running. And so these are just some tests that I have pre-written, and hopefully they go. Going very fast, yes. Wow, so we already are passing one test, and that's just because we have enabled this ability for a registration function to do work. Okay, fantastic. So we also know that this registration function can optionally, not all the time, right? Sometimes it might just return nothing, can also return a deregistration function, right? That is to say, a destructor, right? And so our library, one of the goals that we had in mind was we wanted to be able to have some kind of register teardown and make sure we call that teardown when things are ready, right? So let's actually grab that thing. Let's say destructor equals the result of that thing, and so we actually know that const unsubscribe. So this is a function, and we know that inside this function we need to call that destructor. And then of course we can pass unsubscribe. So now we have even less type errors than we had before. So we have promised TypeScript that we would return something from subscribe that has a dot, from subscribe that has a dot unsubscribe. So we've done that. It's just a function. And we know that we want to call the destructor in here. And there's a type error here, you notice, because, sometimes we might return void. So we can do something like this. Type of destructor equals function. Then we'll go ahead and actually call it. All right, so let's see how our tests are running here. They're doing their thing. We'll come back to that. Okay, so now we actually have two test passing. So this test right here probably has to do, and maybe we'll take a look at these tests in a moment. This test probably has to do with making sure that this deregistration actually occurs and that lazily we are constructing these things. So there's some more tests here, and these have to do with these other kinds of constructors that I was planning on writing. So let's actually go ahead and fix these, right? So by the way, we have only written about 15 lines of code, and we already have a fairly comprehensive observable library. Part of the goal of this video is to just show you actually how simple observables really can be. So again, right, observables are a relationship, a function that can be called that describes the relationship between some callbacks, some signals, next, error, and complete, and some producer. This registration function is the producer. And of course, that producer may optionally have a destructor, which occurs on unsubscription. Wow. We've already done so many of our requirements just by writing these 15 lines of code. Let's actually take a look at these requirements again, just to remind ourselves. So we definitely have all three kinds of signals. We have not really handled this. So there is a problem with our library, and that is if somebody calls error or complete, we're not terminal. We don't stop. There could be a case where someone calls error and then they call next. That should actually be illegal in our library. We don't really want that next to throw an exception or anything like this. We just want it such that if somebody does happen to call next after they have called error or complete, we don't pass that value through. Right now, that will occur. We already know that our implementation is lazy because this registration function is not called until someone calls subscribe. We know that, and we're pretty confident they're reusable. And why are we confident they're reusable? Well, because every time somebody calls subscribe, we recall this registration function and we reconstruct a safe observer for that new registration. These are also as synchronous as possible. You notice we have not used promises anywhere. We have not used async await, nothing. This is all just synchronous JavaScript, right? Now, there is a key here. We have allowed the registration function to use async code inside of that registration function should it choose to. And so it may register calling some of these callbacks at a later time. For instance, it might use set interval or set timeout, or perhaps it registers an event, right? An event listener, or some other kind of asynchronous code can actually happen in here safely, but it doesn't have to. And also, we have begun to handle this requirement of register teardown, right? So we have listened for a destructor, and when someone unsubscribes, we do call it for that person. All right, so let's actually start to write some of these constructors, right? Just so you can see an example of creating observables, right? So I know I need to call create, and I know I need to pass a function that given an observer does something, right? And so my of is really, really simple. It's about as concrete as you can get. Okay, and there we are, and that is the implementation of. So notice this is fully synchronous code. There is no async anywhere to be seen, but the idea is we just iterate through values. We call next for all of them, and then when we're done, we say we're complete. There will be no more values after this. And so to see an example of this, let me actually pull up the tests. So let's see if we can find the of. Here we go. We can see that, so I've written a helper function for tests where I can convert an observable into an array so that I can call equality checks on it. So essentially of nothing is empty array, and of 1, 2, 3 is the array 1, 2, 3. Fantastic. Wow, we've done it. So let's actually make sure that that test is passing while we're waiting for that to run. Okay, so we notice we have some more tests from promise, etc. Let's make sure. Look at that. Basic sync construction of. All done. Yes, beautiful. Okay, so let's try our next constructor. another example of just creating observers, right? So we have described a relationship between an observer and a producer, right? So this basically, this for loop is our producer, right? All right. So from event is a little bit more complex. And so we are given an event source and an event name, and we register that callback and start listening. But I like this example because we will actually use a destructor. So notice how here we had no destructor. There's no cleanup from this code, but we will have one here. So let's go ahead and say, what is an event source, an event emitter? So an event emitter is something that has add event listener and remove event listener. And that's it. So let's go ahead and do that. So I can say event source dot add event listener. And so I get to pass the event name and the idea here is every time that event source emits event name, we get a callback and we call next. We're just going to keep publishing these things. We don't have a natural complete anywhere. We don't know how long this thing is. In this exact implementation, there is no complete. This event emitter doesn't tell us anything about that. So we have no other callbacks we want to call there necessarily. And then so finally, we need to make sure we call event source dot remove event listener, event name. And so actually we've made a mistake here. We need to have a reference to this thing. So let's go ahead and do that. All right. And there we have it. We've done it. So again, registration occurs. We lock in a callback on this event name. And then when we're done, when we want to clean up, we call remove. And we know exactly what to remove, exactly when. So let's see how this is going. Hopefully our pass are testing. Look at this. Oh my goodness. Tests are passing. We have from event. All right. And let's try this last one. So this one's a little bit interesting, and I've chosen to include this example because we will use the error callback. So as we all know, promises have then and catch. Those are our two subscription callbacks, right? So I know that I can say source dot, let's say it like this, then value of type T. And so I'll go ahead and do the only thing I can do. The only thing that makes sense is I can call next with value. And I also know that since promises are supposed to only emit once with one value, I can actually call complete. And this will just alert the subscriber downstream that, hey, like this promise is done, right? And then of course, we also need to handle our error case. Let's go ahead and say observer.error e. And that's it. We're done. And so we have converted a promise into an observer, into an observable. That observable will either emit one value and then complete, or it will error. Beautiful. And let's make sure our tests are passing. Look at that. All of our tests are now passing. Let's actually just glance at some of those tests just for some more complete understanding. So here we go. We're creating an observable that when it's registered, we just increment a count. And that will allow us to make assertions on that count given how many times this registration function is called. And we know this is a requirement of our implementation that every time subscribe is called, even though it's the same observable, this is the same value, every time subscribe is called, we want that count to increment. We want that registration function to have been called again. It's really what this test is all about. We're also making sure that unsubscribe, we can call it multiple times and it doesn't ever change the count. We already looked at this test. This is pretty straightforward. Here's an example of creating an observable from a promise. Pretty straightforward. We expect that observable to emit just one value, which is in this case the number 1. Here's an example of a promise that is an error. We're just making sure that we never ever get the then case, and we get an error when we expect to. From event, again, this is a little bit of some setup code to actually create a fake document object. So I don't have a browser running here, so I've just kind of created what you might consider like window.document, for instance. And so I'm kind of keeping track of all the events that were actually called with next, right? So I subscribe to fake document.click. And so every time the click event occurs, I'm just going to keep track of these results. So I'm calling click, and I expect the emissions to be 10 and 20. Then I unsubscribe, and I still expect the results to be the same, and I expect callback to be undefined. So this callback is, of course, we notice that we null it out, we undefine it in the remove event listener, and this is just one way of asserting that, oh, that deregistration function actually occurred. And here's an example of an asynchronous test. We're just making sure that async code works as well as sync. So again, inside this registration function, I'm allowed to do async code. All of these examples up here have been pretty much all sync, but here I'm calling set timeout. So for instance, I'm calling next after 0 seconds, calling next after 0 seconds, and then finally completing. And so I expect at the end of the day, 1, 2, 3 to have been emitted. As I mentioned earlier, there is kind of one final problem. This is really the only thing we need to do to get all these requirements is these error and complete callbacks, they should be terminal. And that is to say that once either one of these things is called, and also you could consider when someone calls unsubscribe kind of in the same vein, but from the other side of the pipe, we want them to be terminal, which means that that's the end, right? Like we should basically never ever allow next to happen again, or error to happen more than once, or complete to happen more than once. So I have gone ahead and I've written a new test, and let's just briefly take a look at that test. So it's in here. So I've written this thing, and for now it's the only test I'm going to run because we know the other ones are passing. But essentially the gist of this test is we want to make sure that once we call complete or something else, or we call unsubscribe, we want to make sure that these counts that happen on registered on teardown. So for instance, I'm making increment, the thing that changes the count, this registered callback, we want to make sure that happens exactly once. And we also want to make sure that these next and complete and these kinds of things are all terminal. And so I'm not going to go through the exact details of how this test works. You can take a look at the code if you're super interested. But the idea is our goal is to make this thing pass. And I think that the actual implementation will be more clear than the test. So let's go ahead and do that. So I have made basically no changes to the code. I have just changed one of these names. I think we had called this destructor a moment ago, but I have since changed it to register destructor, which is what it is in the GitHub code. And I've also changed these functions. So previously these were something like callbacks or no-op or whatever. I've deleted that no-op. That won't be quite sufficient enough anymore. We're always going to pass a function, so we know that these functions are always defined and safe for this registered consumer to call. But we're going to change the implementation of these a little bit. And the reason we need to do that is because we need to make sure that basically need to put a check in all of them to know if this behavior, this observable is still open, so to speak. So actually, I'm going to go ahead and do that right away. Let's actually just call something let open, and we can, of course, start it as true. We know that when someone calls subscribe, this instance of the observable, this subscription of the observable, is in fact open. We just also have to do some things like check inside of each one of these callbacks. Oh, hey, are we still open? Let's go ahead and do that. If open. If we are open, then it is, of course, safe to call callbacks dot next. And so we also know that next may not be defined, so we're going to use this kind of safe callback version. This is from JavaScript. This is kind of like, oh, if this is null, it won't crash. And actually, let's make this super, super clear. We can just say something like this: callbacks.next, and so that way we know, right? These two codes. I just wrote it this way because this is how I wrote it in the code that is on GitHub, and I just want them to be in sync. Okay, and so we can actually basically duplicate this, right? Error. Except we want to pass error through here, and same thing here. We want to say complete, and there's nothing to pass. Okay, so we have already kind of done our check on all of these callbacks to make sure they're safe. The only thing that's really missing is we need to, in some place, we need to turn open to off. We just, at this point, we've done our checks, right? We know that the stream is still open before we actually call one of these functions, but there's another part to this, which is we, of course, need to turn open to false at some point. And so we kind of have a natural place to do this. It's inside of our unsubscribe function. So I'm just going to flip this. And I'm also going to take this and I'm going to define it up here. Just move it up. Now we have a bit of a kind of a chicken or egg problem because inside of our unsubscribe function, we are using register destructor, even though that's kind of defined after. Technically, I think this is totally legal, but what I'm going to do instead is I'm just going to, just for clarity, I'm going to register, I'm going to create the variable name up here. Register, and it's the return type of register fn. Right. And so, of course, we initialize it to undefined. This is not necessary in this case, but I will do it. And we set it there. And so all we need to do is, if we are open, call unsubscribe. And again, same thing down here. And so both of these will, if they are open, they will call unsubscribe. There is one final thing here. Well, I guess there's two things. The first thing is we do also want to make sure that this register destructor is only called one time. We are probably safe from this by checking open every single time. But just to be safe, what I'm going to do here is probably also for sort of memory reasons, right? We can drop our reference to this register destructor. We don't need it anymore. And this actually kind of, because of this if statement, once we call this thing, we will never ever call it again. This will become falsy from that point forward. Now, there's one kind of trickiness to this whole thing, and this comes back to that kind of chicken or egg thing, which is that since observables are allowed to be as synchronous as they'd like to be, it is possible for someone to call complete right away. And technically, if they call it right away, sort of synchronously inside of the register fn, this will have not returned yet, which means that this registration function has not been registered, right? This destructor has not been registered, and therefore we didn't actually call the cleanup function. So we do need one final thing here, which is if not open, we can go ahead and call unsubscribe. So this enables it such that if you call complete right away or error right away, we will unsubscribe, which will turn open to false, but it won't call the destructor function because it hasn't been defined yet. But then after the fact, if somehow this became closed during the initial registration, we will be sure to actually call that function. And I think that's it. This is our implementation of observables. Let's double check and make sure our test is passing. It is in fact passing, and we can double check that all of them are passing. Well, this is running here, and in fact they are. And so this is it. If you really are wondering how observables work under the sheets, this is the whole implementation, or at least one possible implementation. And approximately speaking, it's about 30 lines of code, maybe 40 lines of code. And so you can see that actually these things aren't that complicated. They ultimately, the observable abstraction comes down to pub sub, right? And that pub sub occurs in a safe and constructed way that has the possibility of doing something on unsubscribe. And so you will see this exact abstraction in kind of various shapes all over the place. I can't tell you how many times I'll look at some implementation of some library and they have like hand rolled their own kind of mini version of observables to basically get something that has some signals and a registered destructor, which is exactly what this is. So the only other thing I'd like to end with is just a brief talk about operators. So, I mean, the thing about observables is usually actually what gets all the attention is actually operators and not observables. So people talk about things like switch map and filter and all these other things, and that's what really makes observables powerful, because of these large amounts of composition you can do. And for time's sake, we're not going to actually write these out by hand, but I just want to briefly talk about what operators are and how they work, because now we have all the tools to fully understand, right? And so I have made one change here to the interface of Observable. I've added this pipe function. So not only can you subscribe to an observable, but you can call pipe on it. And so you can pass any number of operators. Operator functions is the type I've used, and it will return a new observable. And so if we take a look at the implementation of pipe, this is nothing special. If you're used to the compose function, or reverse compose in this case, I guess, this is just take all of these operations, start with the original observable, which is the thing we have called, create returns an observable. We're going to take that original observable, and we're going to call every single operation in order, returning the result. And so here's just some TypeScript to get the types to line up. But essentially, one by one, we call these functions in pipe to get a new kind of observable with new behavior. So let's actually just take a look at some of the tests that I have previously wrote. So here's some tests for some operators. So I've written some like map, filter, start with, etc., etc., etc. But here is this composition I was talking about. So I have a basic observable, and actually this is defined up here as the observable 54321, and we called pipe, right? And so first we call filter on it, then start with, and whatever. And the result of this is first taking basic, then calling filter on it, then calling start with on it, then calling start with on it again, and then calling map. And so each one of these operators has the ability to take the observable in and some configuration. So for instance, filter has been configured with a predicate function, start with has been configured with a original value, etc. And we can manipulate the result. So here, basic observable started as 54321, and we ended up with a layered observable, if you will, which has all of this behavior built in. And so let's take a look at an example of some of these operators. So as we know, operators are nothing more than a function that takes an observable and returns an observable. And so here is map, right? Map takes, in this case, takes some configuration. It is a function that takes some configuration, which is a projection function, right? And then it returns an operator. And that operator takes an original observable and returns a new observable. And how we create observables is with create, right? That's our main API. And so let's take a look at actually how map works. It says, oh, when you subscribe, I will take all of the original behavior of the original observable, the original observer, do the exact same thing, except in next, I'm going to call that projection function. And when I'm done, I'm going to unsubscribe. Our actual deregistration function is unsubscribing to the original observable. And so this is actually really straightforward, right? We don't do anything special, right? We're just a function that creates a new observable given an original one. Let's take a look at filter. This is almost identical implementation to map, just slightly different things. So our configuration for filter is a predicate function, but again, all operators are just functions, so they must return a function that takes an original observable and returns a new observable. So given the original one, we're going to subscribe. We're going to keep all the same behavior, so errors and completes are going to work exactly the same way. But on next, we're going to check the predicate before we call next. So notice how in both of these cases, we have taken an original producer and we've slightly modified it so that our downstream observer gets a slightly different behavior. You're kind of acting as a middleman. Let's take a look at start with. So this is an operator that, of course, adds a value at the beginning of any observable. So again, it's very simple, right? We have some configuration, which is our initial start value. We have an original observable given to us via a function, and we create a new one. And the creation is quite simple, right? We just right away we just start the downstream subscription with that start value. That was configuration, right? Then we subscribe, and we don't change, actually in this case, as opposed to filter and map, we don't change anything about the subscription, right? Next, error, and complete, they all happen the same way for downstream. We're just kind of prepending a value at the beginning of the stream. Here's an operator called take, which has a limited number. So the way is, if you have an observable that emits infinite values, maybe you only want the first 5, right? And so here's an example of where observables can have some internal state, right? So we have some kind of limit. Let's say we start at 5, for instance. We have a function that takes an original observable. It has all the same behavior. We subscribe in the same way, but every single time a next value happens, we do publish it, but we decrement that limit. And if we get to limit 0, we complete. And so we are also guaranteed, because of the implementation of our observable library, that when we call complete, we don't have to worry about accidentally calling next anymore. This will automatically cancel everything and sort of unsubscribe and call all the destructors as needed. And that's it. That's the implementation of take. And I think that's really it. And so, of course, all this code will be available. It's, again, at the end of the day, if you don't count types and things like this, our actual create function, which is the most important part of the thing, is about 50 lines of code, including the pipe operator. Well, thank you for joining me. This has been a fantastic time. If you have questions, concerns, feelings, whatever, you can always leave comments on the YouTube video itself. Thanks for joining.